Last time we started talking about how to find the scale factor when I'm talking about similar polygons. Today we're going to continue that topic, but we're just going to dive a little bit deeper where we're going to relate the perimeter and the area between similar polygons. So if I look at example 4, this is just a nice review. It says scale factor from A to B equals 5 to 6. So I can just rewrite that and say 5 over 6. That means the same thing. So if I come over here and I write 5 over 6, I'm going to set up my proportion. I'm not going to look at my two shapes. I have my smaller shape, which is A, my bigger shape, which is B. Since my smaller number in my scale factor is on top, the smaller shape is also going to be on top. So since 5 is my smaller number, 3x plus 3x plus 11 relates to my smaller shape. That also goes on top. So 3x plus 11 over my bigger side is 42. That goes on the bottom because my bigger number of my scale factor is on the bottom. So now I'm going to cross multiply. So 5 times 42 is 210. And then I have to distribute 6 to 3x and 6 to 11. So I have 18x plus 66. So now I'm going to subtract 66 on both sides. I have 144 equals 18x. So x equals 8. And I'm done. So now we're going to go ahead and we're going to look at this problem. It says, given the similar figures, find the scale factor from the large figure to the small figure. So since I'm starting with my large, that's my original. I'm going to the small, that's my scaled. So it says find the scale factor. So I'll just use S for scale factor. S equals, how do you find the scale factor? Scaled over original. So looking at my scaled item, which is this rectangle, what's one of my sides? 6. 6 over, what does 6 correspond to on the original? 18. That is 1/3. So my scale factor is 1/3. So now it says, now find the perimeter of each figure. So if I go through this and I want to find the perimeter, how do you find the perimeter of something? Well, you add up all the sides. But notice I don't have all the sides of my rectangle. If this side's 36, I know this side's 36. And if that side's 18, I know this side's 18. So in my calculator, I'm going to do 18 plus 36 plus 18 plus 36 to get my perimeter. So I'm going to write perimeter of the big shape, so subscript B. The perimeter is 108. Now I'm going to find the perimeter of the small rectangle. If this side's 6, I know that side's 6. And if this side's 12, I know that side's 12. Find the perimeter, add up all my sides. 6 plus 12 plus 6 plus 12 is 36. So now it says, write the scale factor of the perimeter from the large figure to the small figure. So if I look at my perimeters, my original perimeter is the large figure, so that's this one, so that's O. And my scaled factor is the one that I'm going, so that's S. So now I want to write the scale factor of the perimeter ratio, so I'm going to do scaled, which is 36, over my original, which is 108. So now I have to simplify 36 over 108. So I'm going to type that in my calculator, and I'm going to do 36 divided by 108, and then I'm going to hit math, enter, enter, and I get 1/3. What do you notice about the perimeter scale factor and the scale factor of sides? Well, I notice they're the same. So we have a lovely theorem. Perimeter of similar polygons tells me the ratio of the perimeter of two similar figures is the same as the original scale factor. So if I know what the original scale factor is, the perimeter ratio is the exact same thing as the scale factor. Makes life nice and easy. Scale factor, perimeter ratio, they're the exact same things. So let's go ahead and let's look at these practice problems. It says, if the given similar figures have a scale factor of 3 to 8, what would the scale factor of the perimeters be? So since my scale factor is 3 to 8, what would my perimeter scale factor be? Well, it's the same. So 3 over 8. If you look at the next one, it says a polygon has a side length of 37. A similar polygon has a corresponding side length of 311. What do you know about the perimeters of the two polygons? Well, let me first find the scale factor. So scale factor, it says a polygon has a side length of 37, and a similar polygon has a side length of 111. So since I'm starting with 37, that's my original. So I'm going to do 111 over 37 because of scaled over original. So my scale factor equals 3. So if my scale factor equals 3, what do you know about your perimeters? Well, my perimeter just increases by a multiple of 3 as well. So my perimeter ratio, perimeters, multiply by 3. That's all a scale factor ratio does. So now go ahead and pause this video, and I want you to try the last one on your own, talking about a triangle and a similar triangle. And when you finish this, unpause it, and the answer will be on the board. You should have gotten a scale factor for the perimeters of 2. So when you're good, go ahead and flip your paper. Alright, so look at number 4. It says a triangle has sides A, B, and C. The scale factor, the sides of a triangle are scaled by a factor of 10. What would the formula for the perimeter of the second polygon be? So let's think about this for a second. I'm going to draw a triangle, and I'm going to label it A, B, and C. And then the sides of a triangle are scaled by a factor of 10. So to get to the next triangle, it's going to be 10A, 10B, and 10C, right? So now it says, what is the formula of the perimeter of the second polygon? So here's my second polygon. How do you find the formula? Well, it's going to be 10A plus 10B plus 10C. Why I'm adding up? Because that's how you find perimeter. You add up all your sides. You could have also written 10 times A plus B plus C. Go ahead and pause this video and try example 5 on your own. When you finish, go ahead and unpause the video, and the answer will be on the screen. You should have gotten 1/8. If we go ahead and we look at number 6, it says, what is the perimeter of the larger similar polygon with a scale factor of 3? So I know my scale factor is 3. So I know S equals 3. What about my perimeter ratio? If my scale factor is 3, I also know my perimeter ratio is 3. So, and you could do 3 over 1 if you wanted to really turn it into a ratio. So it says, what is the perimeter? So since I'm wanting to look for the perimeter, which ratio do you think I want to start with? Do you think I want to start with the scale factor or the perimeter ratio? Well, I obviously want to use the perimeter ratio because I'm looking for the perimeter. So I could go ahead and find the perimeter of this shape, no problem. 5 plus 4 is 9, 9 plus 9 is 18, 18 plus 7 is 25. So that's the perimeter of the little trapezoid. I now want to find the perimeter of the big trapezoid. So I do this the exact same way I did it on the other side when I was looking for a missing side. I start with my ratio. The ratio I'm using is my perimeter ratio, so 3 over 1 equals. Now, the bigger number relates to the bigger shape. The smaller number relates to the smaller shape. So go over to this picture here, P equals 25. Was this the smaller shape or was this the larger shape? Well, this is the smaller shape because it says I want to know what the perimeter of the larger shape is. So since 25 is the smaller shape, 25 relates to the smaller number in this ratio, which is 1. Since 1 is on the bottom, 25 is going on the bottom. I want to know what the perimeter of the big trapezoid is, so I put X on the top because the top relates to the bigger number. So now I'm going to go ahead and I'm going to cross multiply, so I have X equals 75. So what this means is the perimeter of the larger trapezoid is 75 units. Notice here, we kind of jumped the gun here, but that's all right. It says, when finding the perimeter of a similar polygon, you set up the proportion the same way as before. You would set it up with perimeter ratio always goes first. And then I would also set up big number relates to big shape. Little number relates to little shape. Oh, instead of little, let's say smaller shape. So just like I explained up before, I set this up the exact same way. Start with the perimeter ratio when I'm looking for perimeters. When I'm looking for sides, you do your scale factor, which can also be called a similarity ratio. Since I'm looking for the perimeter, the smaller number relates to the smaller shape, the bigger number relates to the bigger shape. So if I come over here, it says, given two similar trapezoids with a scale factor of S of 5/7, find the perimeter of the bigger trapezoid. So I know my scale factor is 5/7. What's my perimeter ratio? Well, my perimeter ratio is still 5/7. I know they're the same. So because I'm finding the perimeter, where I'm starting with the perimeter ratio, so I'm going to start with 5/7, and now I'm going to compare it to my perimeters. If I look at the question mark, is that the bigger shape or the smaller shape? Well, it's the bigger shape. So now go back over to my scale factor. Where's my bigger number, top or bottom? It's on the bottom, so X goes on the bottom. If I go over and I look at P equals 18, P equals 18 is the smaller shape. So go over to my scale factor. My smaller number is on the top, so it relates to the top, so 18 goes on the top. I'm now going to cross multiply and solve. So when I cross multiply and solve, I get 5x equals 7 times 18 is 126. Sorry, my dog's playing with his toys in the background. So now if I divide by 5, what does x equal? 25.2. So I want you to go ahead and I want you to try this problem on the bottom by yourself. And when you finish, unpause it, or if you get stuck, unpause it and I'll go over it. So if I take a look at this, it says two similar polygons have a scale factor of 2/3. So I instantly write S equals 2/3 and P equals 2/3 because I know they're the same. It says the larger polygon has a perimeter of 32. What is the perimeter of the smaller polygon? So since I want to know what the perimeter is, I'm using the perimeter ratio, so 2/3. Now I have to look. It says the larger polygon has a perimeter of 32. So since my larger polygon is 32, on my scale factor, my bigger number is down here, so 32 is going to go on the bottom. What is the perimeter of the smaller polygon? Smaller numbers on the top, so X goes on the top. So now I'm going to cross multiply. I get 64 equals 3x. So X equals 21.3. When you're good, go ahead and flip to the next page. You are going to try 3 and 4 on your own, and then I will answer questions on those next class. I'm going to go ahead and skip down here to this next part. But these two problems, 3 and 4, are expected to be done by the time I see you next time. So if I look at the next one, it says, given the following similar figures, find the scale factor from the large figure to the small figure. All right, so large figure is the original, small figure is the scaled. Scaled over original, so 6/18. So my scale factor is 1/3. Now it says find the area. How do you find the area of a rectangle? Well, it's length times width. So perimeter area of the big one, 18 times 36, 648. So the area of the smaller rectangle. 12 times 6 is 72. So now it says, now write the scale factor of the areas from the large figure to the small figure. So my large one is the original, the small, and I'll put it color as O, and small is my scaled. So scaled over original, I get 1/9. So the big question is, how do I get from my scale factor to my area ratio? Well, notice they're just squared. 1 squared is 1, 3 squared is 9. So the perimeter ratio we learned on the last 2 pages was that they were the same, but the area ratio is actually the squared of the scale factor. So, area of similar polygons theorem, it says the ratio of the areas of 2 similar polygons is the scale factor, if I can spell, scale factor squared. So if I have my scale factor, and I'll put this in color over here, and I'm going to say my scale factor is A over B, what do I know about my perimeter ratio? Well, my perimeter ratio is going to be the same. That's going to be A over B. And what do I know about my area ratio? Well, it's squared, so it'll be A squared over B squared. So whenever I'm solving problems that involve ratios and scale factors, I always write SPA on my paper. SPA. S for scale factor, which can also mean similarity ratio. P for perimeter ratio. A for area ratio. You might also want to put somewhere scale factor equals similarity ratio. Similarity ratio. If you hear those words, they just mean the same thing. All right, so let's go ahead and look at these examples. It says, given my scale factors 2/3, so S is 2/3, what's the perimeter ratio and the area ratio? So my perimeter ratio is going to be the same, 2/3. My area ratio, 4/9. 2 squared, which is 4, 3 squared, which is 9. If you look at the next one, given 2 similar polygons with a scale factor of 4 to 5, so that means S equals 4 over 5. What is the perimeter ratio? What is the area ratio? So what do you know about the perimeter ratio? It's 4 over 5. What do you know about the area ratio? 16 over 25. All right, go ahead and flip your paper. Last page. I have 2 pentagons. They're similar. It says, what is the similarity ratio? So notice we just talked about similarity ratio on the other page. Similarity ratio means the same thing as scale factor of the smallest to the largest. So smallest is O, largest is S. Scaled over original. So 10 over 4 is 5 over 2. That's my scale factor. So now using the similarity ratio, what's the area ratio? So if S is 5 over 2, what's A? 25 over 4. So now it says, set up a proportion to find the area of the larger pentagon. So since I'm looking for area, do you think I want to use the similarity ratio or the area ratio to start out with? Well, since I'm using area, I want to start with the area ratio. So 25 over 4. So now I got to come up here and I got to look. It says the area of the smaller pentagon is 27.5. What is the area of the larger one? So 27.5 relates to the smaller shape. So if I go over to my ratio, my smaller number is where? On the bottom. So 27.5 is going to go on the bottom. Since I'm looking for the larger area, x goes on the top. So now I'm going to cross multiply and solve, and when I cross multiply and solve, I get 25 times 27.5, and then I'm going to end up dividing that by 4, and I get 343.8 centimeters squared. Why it's squared? Because it's area. So let's now go ahead and look at number 4. So if I look at number 4, it says my area ratio is 16 over 25. So A is 16 over 25. How do I find P? So you know P and S mean the same thing. So in order, are they equal the same thing? So if A is 16 over 25, what's my perimeter ratio going to be? 4 over 5. Because I just square rooted. Square root of 16 is 4. Square root of 25 is 5. So now it says if my area ratio is 50 over 98, what's the perimeter ratio? What do you notice? What's the issue about this problem? Why is number 5 not as easy as number 4? Well, they're not perfect squares. So when they're not perfect squares, I'm trying to trick you, which means this fraction can be simplified. If I simplify 50 over 98, 2 goes into both, right? So 50 divided by 2 is 25. 98 divided by 2 is 49. I'm now going to square root both of those. I get 5 over 7. That's my perimeter ratio, which is the same thing as my similarity ratio. If I come over here and I look at this problem, it says, what is the area ratio of the smaller square to the larger square? All right, so I can expect you to try to figure that one out. I recommend finding all of SPA. Find S first, then P, then A, and we'll go over that one next class. If I do one more with you, it says if the area of a smaller polygon is 28, what is the area of the larger parallelogram? So smaller is 28. I want to find X, the area of that one. So I got to first start with SPA whenever you have two similar polygons and it's talking about anything comparing it. I always recommend to write SPA on your paper. So notice I'm given side lengths 5 and 15. 5 and 15, does that relate to S, P, or A? Well, it relates to S because sides, scale factor, similarity ratio, it's all the same thing. So notice, did it tell you which one was the scaled and which one was the original? No. So you just get to pick. So S, I'm going to say, is 5 over 15. You could have said 15 over 5. It didn't matter because it didn't tell you. If I simplify that, I get 1/3. So if S is 1/3, P is going to be 1/3. And what's A going to be? 1/9. So the directions say what is the area. So since I'm looking for the area, which one of these ratios do you think I'm starting with? S, P, or A? Well, I'm starting with A because A for area. So that's going to be the start of my proportion. And now I relate little number to little shape, big number to big shape. So 1 is my smaller number, so my smaller shape has 28. 9 is my bigger number, so my bigger shape is X. So cross multiply, I get X equals 9 times 28, which is 252 meters squared. So go ahead and do this last problem on your own, and then we'll answer questions next class.